So in this session we will continue the legacy of name reaction series, okay, because we have already completed 10 name reactions series is already uploaded on the YouTube channel, okay. So this is the 11th lecture series on the name reaction, and today we were gonna discuss benzilic acid rearrangement, okay. So this is also a name reaction. You might be familiar with that, but this is the basic. I will tell you all the steps, all the mechanism, very step by step, detailed full mechanism of this reaction. Why the OH minus react there? Why the OH minus will not act as a base? Why it's there so? Like blah blah blah. All the things means all the things. I will gonna discuss all the things, all the mechanisms in this session, okay. And you already seeing on the screen, this is the general scheme of the reaction, okay. This is the general scheme of the reaction. So you are seeing here, this is a substrate, this one is a substrate, that is called benzil, okay, that is called benzil. Why we call benzil? Because it's a 1,2 dicarbonyl compound. Why so? Because here is a 1 position and here is a 2 position, and on the 1 and 2 position there are a carbonyl group present, C double bond O group is present, okay, and 1,2 dicarbonyl group is present, 1,2 dicarbonyl group is present in this substrate, and here is a pH is attached. What is pH? pH means this, either it's the R group or whatever you want to join here, means you have to replace one H from this position and add some different groups. That is called pH, okay. So this is a pH group is attached here. Let me clear this, okay. So wait, let me clear this, because okay, fine. So this is a substrate that we call benzil. Why we call benzil? Because it is a 1,2 dicarbonyl. It means on the 1 position and on the 2 position there is a carbonyl group is present, C double bond O is present, and the pH is attached to both the carbonyl, okay. So this is the benzil, and here we have taken the reagent. This is the base KOH, but it works as a nucleophile in this reaction. I will tell you why it's so, okay. And this is the product you will get after this mechanism, and this is called benzilic acid, and that's why the reaction of the this reaction name is also a benzilic acid rearrangement. It means that the formation of a benzilic acid basically by the help of rearrangement. How it occur, how it will happen, I will tell all you these things in the next few minutes, okay. It is just the summarize, okay, what will happen in this reaction by the overview of this reaction. It is the general scheme of the reaction. This is called benzil substrate. We have taken a reagent here KOH, and we get the benzilic acid as a product. But how we get, we will discuss. Now let's start. What is the mechanism of this reaction? Okay. So let me clear all this stuff. Okay, fine. So we have generally, I have taken here example pH this, okay. This is a 1,2 dicarbonyl compound that we call benzil, and here we have taken a reagent that we KOH, right? And you know that, let me increase the brightness of my screen, okay, fine. So this is the KOH, and you know that this is a base, right? This is a base, already you know that. And what is the work of base? Work of base is to take the proton, is to abstract the proton. Work of base is to abstract the proton, the acidic proton, right? The acidic proton. Okay. The work of base is to abstract the acidic proton. But in this compound, but in this substrate, there is no acidic H. There is no acidic H. There is no acidic H present in this substrate. In this substrate. So that's why this QH, this OH minus will not work as a base. Will not work as a base. So how it will work? The OH minus will work as a nucleophile. The OH minus work as a nucleophile because there is no acidic H in this substrate, so that the base will take proton, and that's why due to absence of acidic H, and that's why this OH minus will work as a nucleophile in this reaction. Okay, so this is clear. You might be want to take a screenshot. You can take. Okay, I'm gonna clear it. Okay, so now clear this and we move to the next step. This is my just information to tell you that why we here not why this OH minus is not working as a base, because you already studied that in the books, in the colleges, in the schools, that the OH minus will work as a base. But it depends the condition of the reaction, the condition of the substrate, if it either have an acidic H or not. If not, then it will work as a nucleophile. Okay, and also many other conditions also to decide the base will work as a nucleophile or as a base, or the base will take proton, right? We will discuss all about these things in the next video. I will make a separate video on this, when the base work as a nucleophile, when the base work as a takes proton. Okay, for now in this reaction the OH minus will work as a nucleophile because there is no acidic H present in this molecule. Okay, now we have to move forward. Now we have to move ahead. So let's start. So we have, here is a pH. Here we have a pH, double bond O, carbonyl, then again pH, and we have taken here is the OH minus, right? K plus OH minus. K plus is the counter ion, right? And this OH minus, because it will work as a nucleophile, and we know that in this substrate, this carbonyl position are both identical, and along with identical, these two are identical carbonyl, and this carbonyl both are electrophilic center. Both are electrophilic center. Electrophilic center means it have a electron deficiency center, right? And why it's so? Why the carbonyl is, let me make more clear here. Okay, why this carbonyl is acting as a, why this carbonyl is acting as an electrophilic center? Because due to electronegativity difference between of this carbon and this oxygen, because oxygen is a more electronegative than carbon, right? And that's why on the oxygen we have here delta negative charge, and on this carbon here is a delta positive charge, right? Why it's so? Why it will be polarized? Because there is a electronegativity difference between this carbon center and between this oxygen, and that's why this carbonyl is work as electrophilic center. It means the nucleophile will come from outside, and then it will attack on this position, right? This is the main basic idea of the electrophilic center. Okay, electrophilic center means electron deficient position, electron deficient center, right? And a nucleophile will attack on the electron deficient center. You already know that, okay, right? So what happened next? So let me clear this. The happen next is pH, C double bond O, pH, and here is the OH minus. So because they are both identical, so there is no matter where you attack the OH minus, either this position, either this position or either this position, there is no matter at all, okay, because in the last you are gonna find the same product, okay. Either this OH minus will attack on this carbonyl position, and either this attack on this position, okay. You will gonna same product. So I will take only this position, okay. It's my convenience. You can take also this one, right? So when this OH minus attack on this carbonyl electron deficient center, and you know that, and due to attack of this carbonyl center, the pi bond will get shift, the pi bond will get break and goes on the oxygen as a negative charge, and you will get something like this, O minus. Here is a double bond, and here is a pH, and here is the OH, right? Here is the OH, okay, fine. Here is the OH, and you know that when the electrons shifted on the O minus, the O minus charge will always try to get a comeback, okay, will always try to get a comeback. And when the O minus will charge get comeback, what happen? When the O minus charge will get comeback, and this pH group will migrate and attack on this carbonyl, and then this carbonyl double bond will shift at the oxygen as a negative charge, okay. So it is basically aryl migration happening here, aryl migration, okay. pH is aryl, and that's why we call say in this step there is a migration of aryl is happening. How it so? Because the O minus charge will get come back, because the comeback, the carbon has only 4 valency, okay. So that's why the pH will have to migrate. Where it will migrate? The pH will have to migrate at this another electrophilic center present in this molecule C double bond O, and this pH will migrate and attack on the C double bond O, right? And you also have to know that this reaction arrow will be not a single arrow. This reaction have a double arrow. It is a reversible reaction, okay. It is a reversible reaction, right? It is a reversible reaction, okay. So when the aryl migration happening, it will attack on this carbonyl center, and then what happen? Then what we get? We get something like this. Let me make. We get something like this. pH. Wait, sorry. You get something like this. Double bond O. Here OH, and here something like O minus, and here is already a pH, and here this pH, I am that pH who migrate, I am denoting with the white color, okay. This pH is basically comes from the migration, right? Aryl migration happening here, okay. And what happened next? So then we have to do a workup, because we can't leave this molecule as a negative charge, okay. So we have to do in the workup. Here H3O plus we have taken. Workup, how it will happen? Let me show here. OH, double bond O, pH, O minus, here is a pH, and we have taken here is a workup. Workup means just take one hand of water and a sprinkle on the molecule, right? This is a basic workup. This is actually mean a workup, right? So that all the molecule will be gonna neutral. It will be not any negative charge in the product. Okay, that's why we do a workup. Okay, and here you will have H3O plus, so H OH OH positive charge, and because here we have done a workup, so what will happen, this O minus check proton from this H3O plus, and then the H2O will be live in the solution, and then you get product this one, then you get product this one, pH, and here you will get OH, right? And this is your final product of this benzilic acid rearrangement, right? Let me indicate this. This is your product. Okay, this is your product, right? This is your product, final product of this reaction. I have told all the steps in detail, why this happening, why not this happening. Okay, so this is the product of this reaction, and you have to notice that all the steps in this reaction is a reversible step. Okay, there is also a double arrow, and here is a workup, so this is a single arrow, obviously, right? Why we do workup? The workup we do to make the reaction a stop, because if we don't do workup, the reaction, this product will again convert into this. Okay, because this O minus charge will come back, and then again the pH will be migrate at the original position, and then the same we got reactant. So what is the benefit of the reaction? So that's why in the last step we have to do a workup to stop the reaction at this stage. Okay, we have to do workup to stop the reaction, because if we don't do workup, then the reaction will be gonna convert into the previous step, right? I hope it will clear you that what is the use of the workup in the reaction. It is a very important step. Generally people ignore this. Okay, so this is the product of this reaction. Now I am taking some more exciting example, the most blazing example, very beautiful example I am taking in the next. Generally in all the organic name reaction series, I always take two examples, so that to continue the legacy of taking example, and in this also I am also taking another example that is a very beautiful example. You might love that. I am trying to give you feel of the love of the organic chemistry by taking another example, one more example. Okay, that's a very good example. So I am taking such question like this. Very important example. Okay, very beautiful. You never regret after seeing this. You will never forget what is benzilic acid rearrangement, what is the mechanism. You don't have to remember the mechanism. You have to understand what is happening in the first step, second step, why this OH minus will attack on this position, not on this position, right? This all things you have to ask your, wait, I have to make here. Okay, this benzene ring, and now we have this. Okay, so this is the reaction, and we have taken here KOH, right, and here we taken dioxane. Okay, here we have taken dioxane as solvent, right? 30-minute reaction, 30-minute time, and at the room temperature. at the room temperature, right? So this is the condition of the reaction, and you know that it is a substrate, right? It is the reagent, and we have to find product. And because this is a benzyl, why it's called benzyl? Because 1,2-dicarbonyl, this carbon to this adjacent carbon has also a carbonyl. That's why we call this benzyl. It is also a type of benzyl, okay, right? So, and we have taken reagent here KOH, that will work as a nucleophile, right? So what happened next? So the product of this reaction, the mechanism of this reaction is gonna like this. Let me erase this. Okay. So first of all, the OH minus will come, right? It will attack on either this position or either this position. It's your choice. At last, you will get the same product. Okay. Okay. Your choice where you have to attack, right? At last, you will go on the same product. Okay, fine. So I am taking this position. Okay. So when the nucleophile attack on this electrophilic carbonyl center, because why it's so electrophilic? Because the electronegativity difference of this oxygen and this carbon, so it has a delta minus charge and it has a delta positive charge, and that's why the OH minus will attack on the delta positive center here, electrophilic center here. And then what happen? The bond will get shift at this oxygen. This double bond will get shift on the oxygen after the attack of nucleophile, and you will get something like this. O minus, and here is the OH, right? So now what happened? You already know that there is a aryl migration happening here, right? So what happened when the O minus charge will get come back, okay? So which group will migrate? Okay, this reaction is also a reversible step, right? So if this negative charge will goes and come back, then what happened? This aryl group, this group will get migrate on this carbonyl center, and it will get as a negative charge on this oxygen, and you will get something like that. I am telling all the reaction steps by full with mechanism, not just writing direct step. I am doing all the steps, right? Okay, wait. Because this group will migrate on this carbonyl center, right? So that's why we have to do this. We have to show some different colors. Let this will attack on this one position, and here it goes O minus, and here it goes like this, right? And after this, you have to take H3O plus for workup, and if you do workup, then you will get final product, right? It will take proton from this, and it will go like this, and here is your final product, right? Okay, let me draw this one also. I have left this. Okay, fine, right? Okay, here double bond, and here you get a 5-member ring, and this member ring will have something, and here also group is attached, right? And here you have OH, and here you have C double bond OH. This is the final product of this reaction, right? This is the final product of this reaction. Okay, so this is a very important question of this session, very conceptual. Okay, might be some people get afraid by seeing this substrate. Oh my god, this is a very large molecule, this is a very 3-member 4-member ring, what I do, I don't study organic. No, you don't have to worry about that. You just have to apply the mechanism concept. You just have to see the substrate and the reagent, what is the work of reagent. Either the reagent is working as a nucleophile or as a base. If it acting as a nucleophile, then where it will attack, where is the electrophilic center in the substrate. You have to know all this. Okay, right? So this is the final product of this reaction. I hope you will understand the basic essence of the basic concept of the benzilic acid rearrangement. I have tried my full effort to tell you all the steps, all the mechanism, all the reasons behind this reaction, right? Okay, and if you have understand properly, then please like, share and subscribe the channel, and because these things will give motivation to me to make a new videos on it. Okay, and really I love organic chemistry. I want to teach. It's my passion, right? I don't do anything for this money, like I want to earn money from YouTube. Like no. I never think that. I have never thought come in mind like I want to become a very big YouTuber. I want to earn money from the YouTube. No, I have just my passion to teach organic chemistry to all the students in the very simple language, that what I all know, I have to teach you. I am very love to teach someone, to explain someone in a very simple language, and when they get understand, that's the happiness is all for me. Okay, there is no motive to earn money from YouTube. Okay, yes, I only know how to teach in the simple manner language, how to teach in simple step by step mechanism, how the students gets much more benefit. Okay, I want to get all the students to fall in the love of organic chemistry. Okay, organic chemistry is very interesting. You all love when you study this, when you take it as a passion, not as a burden. Okay, fine. So today it's lots of we have discussed, and see you. Bye bye. See you tomorrow in the next session of the name reaction series. We will continue that. Okay, and this is the 11th name reaction series, right? And okay, तब तक के लिए टाटा, bye bye. See you soon in the next session. Keep, share, subscribe and like the channel if you understand this concept properly. Thank you for watching my video.